In 5, we want to find the center and radius of the circle. So first we group the x terms together and leave a blank. And then the y's. And add 2 to both sides. Now we're ready to complete the square. Half is 5 squared is 25. We'll put that on both sides. Half is 3 squared is 9. Put that here. Alright, so now we have x plus 5 squared y minus 3 squared. And here we have 36. So center minus 5, 3. Radius square root of 36 or 6. The slope of the line perpendicular to this line, well, let's put it in the form y equal mx plus b. Divide by 2. So we're talking about a slope that's perpendicular to, the slope of a line perpendicular to this line, so that would be the negative reciprocal of this would be minus 2. And now the slope of a line parallel to this line, again put in the form y equal mx plus b. This line has slope minus 2, and parallel lines have the same slope. So the slope of the parallel line would be minus 2. Here we're looking at f of g of x, so we're doing a composite function. Okay, I'm going to write it like this. G of x is x plus 3, and we're just going to put that into f of x. Here's f of x. Instead of x, put parentheses and put the x plus 3 right here. And that's it. If we want to square out, we have 2 minus x plus 3 times x plus 3 is x squared plus 6x plus 9. Or 2 minus x squared minus 6x minus 9, which is negative x squared, negative 6x, negative 7. Okay, in 9 we're finding some inverses. So let's write the first one as y equal 5 over x plus 3. And then switch x and y. And now we're going to solve for y. So let's cross multiply. And solve for y. Subtract 3x. And divide by x. Okay, in b, we have y equal 5x plus 3. Switch x and y. And start solving for y. Divide by 5. And there's our inverse. Okay, let's look at number 10. It says f of x is a quadratic function with this vertex. And we want to find f of x. Okay, so let's write our quadratic function as follows. A, and we're using the vertex x minus 3 squared plus minus 5, or I'd rather just write minus 5. To find a, we're going to use this information, f of 2 equal negative 1. So basically we're given another point, the point 2 comma negative 1. We'll substitute that in. So the negative 1 is here, and the 2 is here. This is minus 1 squared. This is just 1. Add 5 to both sides, and we have a is equal to 4. So just replace that a with a 4, and there's our function. In 11, we want to find n behavior. So what we're going to do is just pick off the highest powered terms. So we say as x goes to infinity, minus 2x to the 5th over x squared, which is equal to minus 2x cubed, also goes to infinity. And as x goes to minus infinity, minus 2x cubed, sorry, let me change that. Because of this negative over here, as x goes to infinity, this with the negative sign goes to negative infinity. And here as x goes to negative infinity, we have the x cubed going to negative infinity, but because of the minus 2, this is going to positive infinity. In number 12, we're going to do a synthetic division. Since this is a plus 3, we put a minus 3 in the little box and put the coefficients, zeros for missing coefficients. So we have a 1 for x to the 6th, x to the 5th gets a 0, x to the 4th gets a negative 1, x cubed gets a 0, x squared gets a 0, x gets a 2, and the constant gets a negative 3. Put a line here. Start by bringing down the 1, and then we're going to keep multiplying and adding. So here we have a minus 3. We add. Multiply, we have a 9. Add. Multiply, we have a negative 24. And add. Multiply, we have a 72. And now we add. Multiply, and we have a negative 216. Add, and we have negative 214. And once again multiply, and we get 642. And finally add for the remainder, and we have 639. So that's our remainder. And the quotient, we start with 1 power less than x to the 6th. So that would be 1 times x to the 5th minus 3x to the 4th plus 8x cubed minus 24x squared plus 72x minus 214. And this is the remainder. In A, in order to find the domain, we're going to factor the denominator. So this factors into x squared times x plus 2x minus 2. So the domain is x not equal to 0, minus 2, and 2, because those values make the denominator 0. In B, we want to make sure that what's under the square root is greater than or equal to 0. So minus 2x greater than or equal to minus 3, or divide by minus 2, and switch the direction. Okay, that's a 3. And that's the domain. Okay, let's look at C. At C again, we want to make sure that this is greater than or equal to 0 and also not equal to 0. So basically greater than 0 since it's in the denominator. So we have x greater than 5